Hello and welcome back. This tutorial is about Lagrange multipliers. We will take a different look on the way of maximizing function. Let us start with the example right away. So if we wanted to maximize function, multivariable function f of x, y, which is x squared times y, subject to constraint x squared plus y equal to 1. What does it mean subject to constraint? Well, in the picture you can see now how the graph of function x squared y looks like. This is just a three-dimensional function here. Now, how our constraint looks like. X squared plus y squared equal to 1 is just a circle on the xy plane. Now, the projection of this circle, it will be exactly subject to constraint, right? So basically, we take projection of our circle to our three-dimensional function x squared y. And this is what we obtain here. So it shows you all values of the function in the circle, and these are the values which we wanted to optimize. So when we're talking about find maximization of the function subject to constraint, you're really looking for the highest point of this projected circle onto the function. In order to find these points, maximum points of the circle, we wanted to use Lagrange multipliers. The first step in order to do that, we have to rewrite our constraint x squared plus y squared equal to 1 in terms of function g of x, y equal to 0. So in other words, my function g of x, y is x squared plus y squared minus 1 is equal to 0. So what I've done, I just take everything to the left-hand side on my constraint function and just make it equal to 0. The next step is to construct a Lagrange function. We're constructing it in the following way. Apparently, this will be the function of three variables, x, y, and lambda. This is just a Greek letter lambda. And we're constructing in the following way. We take our function xy, f of xy, and we subtract function g of xy multiplied by lambda. In our case, function capital of x, y, lambda looks like this. So we take function f of x, y, which is x squared y, minus lambda times function g of x, y. X squared plus y squared minus 1. Now we're simplifying it. So function capital f of x, y, lambda is equal x squared y minus lambda x squared minus lambda y squared plus lambda. The next steps is to find derivatives of these functions. And we have three derivatives because we have three different variables. This is the function of three variables. So we have to find derivative of this function over x, over y, and over lambda. Now we have to differentiate our Lagrange function. So step 3 is to find derivatives of the function. Since function has three different variables, we have to differentiate it 3 times over each variable each time. So first we find derivative over x. It will give us 2xy minus 2 lambda x. Derivative over y would give x squared minus 2 lambda y. And finally, derivative over lambda would give us minus x squared minus y squared plus lambda. Now we equal all of these derivatives to 0. And in this case, we obtain system of equations. So it's 3 equations with 3 unknowns, and we have to solve the system. For this, I pick first equation, and I will introduce one variable in terms of another variable. So from the first equation, I can write that y is equal to lambda. Now, since lambda is equal to y, I will introduce second equation in terms of x and y only. So from there, I have x squared minus 2 times y times y. So y squared is equal to 0. So we can have that x is equal to 2 y squared. square rooted, positive and negative. So x is equal to square root of 2 times y, positive or negative. Now, third equation we can rewrite in terms of y only. Since x squared is equal to 2y squared, we can write it as minus 2y squared minus y squared plus y is equal to 0. So third equation will give us that 3y squared is equal to 1. So y squared is equal to 1 over 3. Thus y is equal positive or negative 1 over square root of 3. Now corresponding x would be positive or negative square root of 2 over 3. So basically we obtained 4 different points. 1 over square root of 3 times 2 and 1 over square root of 3, and it's square root in there. So it's 2 square rooted over square root of 3 and 1 over square root of 3 is a 1 point. Negative square root of 2 over square root of 3 and 1 over square root of 3 is another point. Square root of 2 over square root of 3 with negative sign, negative 1 over square root of 3. And square root of 2 over square root of 3 and negative 1 over square root of 3. Now we have to look at these 4 points and find which points will give us maximum value of the function. Since our function f of x, y, x squared times y, is negative when y is negative, then these 2 points would not give us the maximum value of this function. And if you look closely, these 2 points will give us exactly the same values. So the maximum value of the function will be attained at the points square root of 2 over square root of 3 and 1 over square root of 3 and negative square root of 2 and square root of 3 and 1 over square root of 3. Now it's your turn to practice.